Welcome back. So now that we know how to use functions to take advantage of some of Python's built-in abilities, let's look at how to create our own useful custom functionality in Python using expressions. So an expression is just a combination of values and operators that Python can evaluate. For example, 2 plus 2 is an expression that evaluates to 4. In this case, the operator is the plus sign that performs the addition operation on the values 2 and 2. So operations, in this context, are just actions that we can perform on values. In Python, we can perform all kinds of operations, like addition, subtraction, multiplication, and division, just to name a very few. The specific operations that are available for us to perform on a piece of data depend on the type of that data. For example, if we have a number, we can add, subtract, multiply, or divide it. If, on the other hand, we have a string, we can concatenate it with another string, but we can't perform math on it. Okay, so now that we understand the basics, let's kick things off by diving into some examples of numeric expressions in Python. First up is addition, which we just saw an example of. 3 plus 2 equals 5. Shouldn't be too controversial. Pretty straightforward stuff. Next up, we have subtraction, which is similarly straightforward, using the minus sign operator we're all familiar with. Things get slightly more interesting with multiplication, where Python uses an asterisk instead of the standard X you might be accustomed to as the operator. Now for division, on the other hand, our operator in Python is the /, as we see here. Now there's actually another flavor of division in Python that's called integer division, which uses not one, but 2 / as its operator. Now the difference here is, integer division returns just the whole number result of the division without the decimal. For example, 3 /2 returns 1, not 1.5. Now this sort of division can be useful in certain situations, even though it may seem a little odd, so it's good to keep in mind. Next up, we have the somewhat exotic and futuristic sounding modulo operation, which uses a % sign as its operator. The modulo operation gives us just the remainder of a division operation. So using 3 and 2 as our inputs, we get 1 as the result, just like in our integer division example, but for a different reason. In this case, 2 divides into 3 completely just one time, leaving a remainder of 1. Now you might be wondering what the heck this could ever be used for. Well, for one thing, it can tell us if one number is cleanly divisible by another. That is to say, there's no remainder when we perform the division. In this case, modulo would return a result of 0, meaning no remainder. That can be handy for things like testing whether a number is even or odd. For example, if I perform the operation 142 modulo 2, I get a result of 0, meaning that 2 divides cleanly into 142, which in turn means that 142 is even. Now, if we get anything other than 0 as the result, using 2 as the second input to this expression, we know that the first input is odd. If we do 141 modulo or %2, we get 1. So we know that 141 is odd. And frankly, 141 is kind of a weird number, am I right? And that cataclysmically awful joke brings us to exponentiation, which is really just raising one number to the power of another. Now in Python, we use a double asterisk for this particular operation. So for example, 3 double asterisk 2, that is 3 raised to the second power, which is more commonly referred to as just 3 squared, returns 9. Basically, we're just multiplying the first input by itself the number of times specified by the second input. So 3 times 3 is, of course, 9, but if we were to change this expression to 3 double asterisk 3, now our result would be 27, which is what you get when you multiply 3 by 3 3 times. Now, when we're piecing together numeric expressions in Python, it's very important to keep order of operations in mind. In other words, the order in which Python executes these operations if we chain several of them together in a single expression. This order pretty much follows what you no doubt learned about and then worked very hard to forget if you're like me in high school math. So an easy-ish way to remember this order is the acronym PEMDAS, which stands for parentheses, exponents, multiplication, and division, all performed left to right, then addition and subtraction, also performed left to right. The parentheses piece is especially important because it allows us to control the order in which these operations are executed just by wrapping certain sub-expressions, if you will, inside of parentheses. As you'll see, this can have a huge impact on the result of our expressions. For example, if we use the expression 3 plus 2 times 4 in code, left to its own devices, Python will give us a result of 11. That's because it will multiply 2 times 4 first, rather than adding it to 3, due to multiplication being higher on the old PEMDAS ladder than addition. It will then add that result of 8 to our first input, 3. What if, however, we want to add 3 and 2 first and then multiply the result by 4? Well, we can force Python to do this simply by wrapping the sub-expression 3 plus 2 in parentheses. This gives us a very different outcome of 20, underlining just how much order of operations matter. Now, the PEMDAS acronym is handy for remembering the proper order of operations, but not everyone, including people who may someday have to review your Python code, may be as familiar with it as you now are. As such, I generally recommend using parentheses to specify which expressions in your code you want to be evaluated first, even if order of operations would have taken care of that for us anyway. So in our first example here, I'd probably put parentheses around 2 times 4, even though it won't change the output in that particular case. It makes the intent of my code clear to both myself and others, and makes sure that I don't make a critical math error because I haven't had my coffee yet and forget my handy PEMDAS acronym. Now, before we go, let's give expressions involving string data some love. After all, boring old numbers should not have all the fun. First up, let's look at text addition, more commonly known as concatenation, which really just means piecing strings together. Not surprisingly then, given the additive nature of this operation, the familiar old plus sign is our operator here. Now, while the concept is straightforward, note that our example here actually involves adding 3 different strings, the second of which just looks like an empty pair of quotes. But they're not entirely empty. There's actually a space, which is technically a text character just like any other, in between those quotes. And we need to concatenate that in between the other 2 strings, so howdy and earth are separated by a space, and not just all one word. Now, an equally valid approach, of course, would be to simply throw the space in at the end of howdy or the beginning of earth. Totally your call, but the first option has the benefit of being more clear and explicit, which is very often a good thing. Now the last, and probably coolest operation we'll look at is text multiplication. That's right, you can actually multiply text strings. Not by other strings, mind you. Hello times world obviously doesn't make a lot of sense. But if we multiply, say, the word hi by the number 3, we get back a text string consisting of hi repeated 3 times back to back. Pretty cool. Now, this kind of math with text strings obviously has its limits. Try dividing a word by a number if you really want to make Python angry, for example. But just addition/concatenation, along with multiplication, can let us do some pretty handy things with text data. Okay, so this has been entirely too many slides for my liking. So up next, let's dive right in to actually coding up some expressions in Python. See you then.